In this video, let's talk about matrix algebra. We're leaving the land of augmented matrices and just talking about general matrices. In this video, we will discuss the operations of addition and subtraction with matrices. Only matrices that are the same size can be added or subtracted. So in order to add or subtract two matrices together, they have to have the same number of rows, and then their columns must also be equal. The resulting size of a matrix will be the same size as the two matrices you added together. So let's let A be this matrix here and B be this matrix here. When I add A and B, it's simple for us to combine each corresponding entry to get the resulting entries of the sum. That's all you do. -6 plus 0 makes -6. 4 plus 5 makes 9. 2 plus -3 makes -1. Let's see what happens when we add these two matrices in the other order. B plus A. So now the B is on the left and A is on the right. Again, I'm just adding corresponding entries. So 1 and 0 make this 1. 2 and 3 make 5. -10 and +1 make -9. These two matrices are the same, so it doesn't matter which order I add two matrices together. That property is known as commutativity. Matrix multiplication is commutative. It doesn't matter which matrix is on the left and which matrix is on the right. Let's again consider the matrix A and the matrix B from the previous problem, but let's go ahead and look at the difference this time. So if I take matrix A and subtract matrix B, again, I want to subtract corresponding entries. -6 minus 0 is -6. 4 minus 5 is -1. 2 minus -3 is 5. 0 minus 1 is -1. 3 minus 2 is 1, and 1 minus -10 is 11. If we subtract these matrices in the other order, so instead of A on the left and B on the right, if we do B minus A, do we get the same answer? So you're still subtracting corresponding entries, but what you notice is that A minus B and B minus A are not the same matrix. They're similar, but they're not equal. So the takeaway from this is that matrix subtraction is not commutative. And that shouldn't be surprising because we know that subtraction with real numbers is also not commutative. So in other words, A minus B does not equal B minus A. Another property that matrix addition has is that it is associative. Associativity means you can group things in an addition problem in any order you'd like. So if we have three matrices, A, B, and C, we can add matrix A and B first and then add C. Or we could add matrix B and C first and then add A. So here's an example. This would be matrix A, this would be matrix B and C, and this side up here. And so when I combine A and B, I get this matrix. And then when added to C, we get this 1, 10, 9, 12. But if I group the other two matrices first, so B and C got grouped, here's the resulting matrix, and then I add it to matrix A, I again get the same answer. So matrix addition is associative. The additive identity matrix is the zero matrix. What that means is if you add a matrix containing all zeros to a matrix, you will get the original matrix back out. 0 is the additive identity with real numbers too. So by adding 4 to 0, we get 4. 7 to 0, we get 7. These zeros don't do anything to this matrix. So we have the additive identity.